Okay, so here we're going to be talking about solving quadratics and polynomials of higher degree algebraically. Now, the first thing you're going to want to do is you're going to want to make sure your equation is set equal to 0, which it already is. All right, so that's a good start. The next thing you want to do is you want to just factor what's on the other side of the equation. So in order to factor this, I'm going to first pull out a 4. And when I do, that's going to leave me with m squared plus 4m minus 21. And then I'll bring down the equals 0. Okay, now I'm just going to take this 4 and bring it down. And since this is a trinomial, I'm going to factor it further. I'm going to set up 2 sets of parentheses. I can put an m here and an m here. I'm just going to come up with 2 numbers that multiply to negative 21 and add to positive 4. All right, so that's going to give me positive 7, negative 3. Now from here, what you're going to do is you're going to set each factor equal to 0. So I have 3 factors here. I have 4 as one factor, m plus 7 is another factor, and m minus 3 is another factor. Your factors are just what's being multiplied together to give me this original expression. Okay, so I usually I call it a t-chart. I basically just put a line in between each factor. And you could just go ahead and set each factor equal to 0. So 4 equals 0, m plus 7 equals 0, and m minus 3 equals 0. So you're going to go through one by one and just solve each of these equations you made. Well, the first equation, 4 equals 0. 4 can't equal 0. 4 is 4 and 0 is 0. They're not equal to each other. So I'm just going to put a little slash through that. That's not even true. The next equation, if you subtract 7 from both sides, it leaves you with m equals negative 7. So there's one value. And then the next one, if you were to add 3 to both sides, we would be left with m equals 3. So if you were to take negative 7 and substitute it back into this original equation, you would get the left-hand side of the equation to equal 0, which is what the right-hand side of the equation says, so that's great. If you were to also then take 3 and replace all the m's with a 3, you would also get this side of the equation to be equal to 0, so it would check out. One other thing I want to point out, if you look at the degree of the equation, which means the biggest exponent, so here it's a second degree equation, it tells you the maximum number of answers you're allowed to have. So it tells you you're allowed to have 2 answers for this equation. All right, now let's take a look at number 2. Now number 2 is not set equal to 0. So the first thing we're going to want to do is let's subtract the 6x from both sides of the equation. You don't even have to show this. You can just do it. And when you do, you'll be left with x cubed minus x squared minus 6x equals 0. Okay, now from here, we're going to factor this. All right, the first thing we could do is we could factor out an x. Now, when you factor out an x, it's going to leave you with x squared minus x minus 6, and then you could bring down your equals 0. And you want to always factor completely. So I'm going to bring this x down, and again, in here, we just have a basic trinomial factoring. So I'll set up my 2 sets of parentheses, and I'll put an x in the first spot in each one. And if we want to come up with 2 numbers that multiply to negative 6 and add to negative 1, it'll be negative 3 and positive 2. Okay, so now we're going to put a line going down in between each factor. And we're going to just set each factor equal to 0. So I'll write x equals 0, x minus 3 equals 0, and then x plus 2 equals 0. Now, when we go through and solve them, this one says x equals 0. We're not going to cross it off like we did over here. Over here, negative 4 can't be equal to 0 because they're 2 different numbers or 2 different values. But over here, x, a variable, can be equal to 0. And think about it. If you took 0 and substituted it into the original equation, 0 cubed minus 0 squared is 0. And over here, 6 times 0 is 0. This actually does check out, so this is one of our solutions. Okay, in the next one, we could add 3 to both sides, leaving us with x equals 3. And then over here, we could subtract 2 from both sides, leaving us with x equals negative 2. And remember, you can always check these by taking your answers and just substituting them back into the original equation to see if they check. Now, 2 things I want to point out. When we looked at this equation in the beginning, it was a 3rd degree equation, right? X to the 3rd, that's our biggest exponent, and we wound up with 1, 2, 3 answers. The second thing I want to point out is when you go to solve these, like, okay, let's look back at number 1. When we had m plus 7, our answer always has the opposite sign. It's m equals negative 7. And when we had a factor of m minus 3, our answer had the opposite sign. It's m equals positive 3. So if you want to skip this step that I'm circling right here, you can skip that. You can just jump down from the factor to the solution. So same thing in number 2. When we have x minus 3, we know we're going to wind up with x equals positive 3. So if you want to skip this step, feel free to skip it. And when we have x plus 2 as our factor, our solution is going to have the opposite sign. It's going to be x equals negative 2. So again, feel free to skip this. Okay, let's take a look at the next 2 examples in your notes. Now, with number 3, this is already set equal to 0. So let's just factor, make a t-chart, and solve. So the first thing we could do is we could factor out a 3, leaving you with x squared minus 16. And then x squared minus 16 is just a difference of perfect squares, so that factors further to x plus 4, x minus 4. And when we make our t-chart, you wind up with 3 equals 0, which 3 can't equal 0, so we cross it off. Now let's do the shortcut. If the factor is x plus 4, our solution is going to be x equals negative 4. And if our factor is x minus 4, our solution is going to be x equals positive 4. So these are our 2 solutions. Now, one thing I want to point out about this question, I don't recommend doing it this way, but if you wanted to, another way you could have solved this question is you could have first just add 48 to both sides of the equation, leaving you with 3x squared equals 48. Then you can divide by 3, leaving you with x squared equals 16. And you could take the square root. But the reason I don't recommend doing it this way is because a lot of people say, all right, well, the square root of 16 is just 4, so 4 is just my answer. But the thing is, when you're solving for an x squared, remember that exponent of a 2 tells us there's 2 answers. It's really going to be positive 4 as well as negative 4. Both of these 2 answers work, because if you go back and substitute in a positive 4 into the original equation, it checks out. If you go back and substitute a negative 4 into the original equation, it also works out. So if you do it this way by taking the square root, you have to remember to write your positive 4 as well as your negative 4. That's why I really just recommend factoring, because then you don't take the chance of making that mistake. Okay, and then finally number 4. So number 4, again, the first thing we want to do is we want to set it equal to 0. So we're going to subtract 5x from both sides, leaving us with x squared minus 5x equals 0. Now, when you factor this, I mean, all you could really do is just factor out the greatest common factor, which is an x, leaving you with x minus 5. And so when we make a t-chart, we wind up with x equals 0, which we don't cross off because, remember, a variable can be equal to 0. And then over here, doing the shortcut, if our factor is x minus 5, our solution will be x equals 5. Now, one thing I want to point out, one thing you cannot do, is if you look at, I'll do it in red, which means you cannot do it. If you look at your original problem, some of you might have been tempted to divide both sides by x. And since x squared divided by x is x, and since 5x divided by x, these x's cancel off, is 5, you'd wind up with x equals 5. But the reason you're not allowed to do that, the reason you're not, okay, I'm going to put a big X, cannot do this, is because if you take an equation and divide it by a variable, what you're doing is you're eliminating one of the answers. Think about it. Doesn't this x squared tell us we should have 2 answers? If you divide by x, you made it into a first-degree equation, x to the first, which means there's only one answer, and that's not true. So never divide by a variable.